All right, welcome to Unit 2, Lesson 9. We're solving linear inequalities, which should be something that's relatively familiar to you from middle school, but we definitely need to review and practice. So the first couple of exercises are just kind of getting you into thinking about what does an inequality mean and how does it work, and then we'll dive into the meat of this lesson with actually solving some linear inequalities in just a moment. So starting at exercise 1, each one of these questions here is just asking you to consider this inequality. 4 is less than 8, and that is a true inequality. 4 is less than 8. So for each one of these things, it says that we are doing something to both sides. Add 3 to both sides, subtract 4 from both sides, multiply both sides by 2, and then divide both sides by something that's in the way. Let's see here. By 2. So when we look at doing something to both sides, that's a property of equality when you do something to both sides. So let's just look at this first one. Add 3 to both sides. So if I add 3, then the new inequality is 7 is less than 11. And the question is it still true? Which, of course, is yes. Yes, it is still true. So when you do something to both sides, it does not change the truth of the inequality statement. Go through and do the same thing that I just did on A for B, C, and D, just to confirm that when you do something to both sides, the inequality remains true when it comes to this particular example. Pause the video now, do B, C, and D. All right, after you have worked out B, C, and D, these should have been your solutions, which you can see that when it comes to adding, subtracting, multiplying, or dividing, in this particular case, one thing I want to point out is that all the numbers that we dealt with in these exercises were positive. So they still remain true. The inequalities are still true. So let's scroll down now to the next exercise, where we're looking at what happens when I do something to this inequality and a negative number is involved. So we're going to multiply both sides of the inequality by -2. So 4 is less than 8 is true, but when I multiply times -2, then it becomes -8 less than -16. Which is not true. -8, remember from our last lesson dealing with number lines and where do the numbers fall on a number line, -8 would fall further to the right than -16, which would mean that -8 is actually greater than -16. What happens if we divide both sides by -2? So 4 divided by -2 and 8 divided by -2. That's going to give you -2 is less than -4, which again is false. So what you see here is that the negative numbers, when it comes to multiplying and dividing, actually change the inequalities and make them false. Here on exercise 3, it's addressing these properties of inequality. So with addition and subtraction, if you add or subtract a number to both sides, then it remains true. But with multiplication and division, let's break that one down a little bit. So if we start out with a true inequality and you multiply or divide on both sides with a positive number, then it remains true. But if that number is negative, then you have to switch the inequality sign. You might recall doing that when you were in middle school. If you multiplied or divided by a negative, you had to flip the sign. And the reason for that is because the negative number makes the sign of the inequality false. So you have to flip it to make the inequality true. For exercise 3, they want you to make up your own inequality that is true, but then becomes false when you multiply each side by a negative. So come up with your own inequality and then move on to the next example. All right, in this example, they want us to actually start solving the linear inequalities. So you're going to solve the linear inequality using inverse operations, just like we were doing when we solved equations earlier in Unit 2. So inverse operations That's talking about the opposite of whatever operation you see in the problem. So for 4x minus 3 is greater than or equal to 5, the first operation that we need to reverse or do the inverse of is minus 3. So add 3 to both sides, which would simplify your expression, your inequality, to 4x is greater than or equal to 8. Your last step to reverse this inequality would be to divide both sides by 4. We're dividing by positive 4, so nothing happens to our inequality symbol. So our final answer would be x is greater than or equal to 2. In part B, they want you to write 5 numbers that make this solution true and then plot them on the number line in part C. So since our inequality symbol has an equal to sign, the first number that makes this true is 2 because your solution can be equal to 2. But the rest of our inequality is a greater than. So give me 4 numbers here. You need to pause for a second to write those 4 numbers down. You can. 4 numbers that are also true in this inequality. So numbers that are greater than or equal to 2. Then you're going to come down to part C and plot your numbers that you selected. I'll start by plotting the 2 on the number line. Since it's an equal to, that 2 gets a solid dot, and we'll talk more about that in a second on the next example. But you're going to put a solid dot on 2 since it could be equal to 2. Whatever 4 numbers you selected in part B, you should notice that they all fall to the right side of that 2 that you plotted. This is called a solution set, and it makes this inequality true. Since the numbers are supposed to be greater than 2 or equal to 2, they are all going to fall to the right of that starting point. Go ahead and finish up your list and your number line now, and then move to exercise 5. All right. So on the next example, we are solving 8 minus 2x is greater than 16. A lot of times people have a hard time when the x is not the first thing that comes in the problem. So part A just wants you to reverse this using the commutative property. So change it to negative 2x plus 8. That's what they're talking about when they say an equivalent expression using addition. They just wanted you to reverse the order. That just makes it a little bit easier to see exactly what steps you're supposed to do. But if you can see what step to do without having to rewrite it, that's totally fine. So now that we have negative 2x plus 8 is greater than 16, it's apparent that the first thing that needs to go is the plus 8. So over here in part B is where you're actually going to solve this. You may have already started solving it on A. That's fine too. We're going to subtract 8 from both sides. And then we get negative 2x is greater than 8. So the next step is to divide by negative 2. Remember what we just saw on exercise 3, that when you divide by a negative, you have to switch this sign because it's not going to be true anymore when the negative comes into play. So your final answer is going to be x is less than negative 4. So just draw some attention to that we switched the sign. So our final answer, x is less than negative 4, says pick a number that is true based on your solution and show that it makes the original inequality true. So any number that's less than negative 4, numbers that are less than negative 4 are going to fall to the left of negative 4 on a number line. Let me go ahead and plot negative 4, and let's talk about what I was saying earlier about the solid dot versus the open dot. Since we don't have an equal sign on this inequality, this should be an open circle. Oh, and I put that circle in the wrong spot. Let me erase that real quick. It should be an open circle on negative 4, not negative 6 where I had it. Negative 4 is your starting point, and the solutions are anything that is less than negative 4. So any number that falls to the left of that number. So whatever number you pick, it just needs to be to the left. So it could be negative 5, negative 6, it could be a fraction, a decimal, as long as it's to the left. Go ahead and pick a number and plot it here. It says graph the solution to the inequality on the number line. So just as I was saying, anything to the left, you're actually going to show it by shading the whole number line to the left. That represents that any of these numbers are possible solutions that make this inequality true. All right, on this last example, they gave you this big complex inequality, and they say here that you're going to be using all the different properties, all the properties that we've learned since the beginning of Unit 2, commutative, associative, distributive, simplifying by combining like terms, all the things. So on part A, it says to use those properties to simplify. So they're asking you to go ahead and distribute, combine like terms, all of that. And then in part B, they want you to solve. I'm not going to do this one for you. I want you to practice using all of those different pieces that we've learned since the beginning of Unit 2. But I will remind you and warn you that your sign in your inequality right now is less than or equal to. But if you are to solve this and you end up multiplying or dividing by a negative, remember that you would flip that sign over. Pause the video now and solve it. I am going to come back on in just a second and put the solutions, but I want you to practice solving it before I start working it out. All right, hopefully you have done your simplifying and you can check your steps along with mine. Here's the simplified work, and then you go over here to B and solve that simplified equation. So if you haven't done that yet, pause and do that now. All right, as you're solving this very last one, I want to pause real quick if you haven't already finished it and take a couple seconds just to notice something here. So typically, you might be inclined to take this 2x and move it over to the 4x so that you don't end up with a negative when it comes to your variables. But because we are dealing with an inequality and not an equation, it's best to solve your inequality in a way that you would have your variable on the left, because when you go to plot it on a number line, the variable has to be on the left in order for you to solve this and plot it correctly. So you see here, I subtracted 4x from 2x to go ahead and get that variable on the left. Since I'm already talking to you, I'll go ahead and finish the problem. We're going to add 19 to both sides, and we'll get negative 2x is less than or equal to 16. You can see that we are about to divide by a negative 2. And remember what happens to your inequality sign when you divide by a negative. So x is now going to be greater than or equal to negative 8. Since we have that equal to, we're going to plot a closed circle on positive 8, or sorry, negative 8, not positive 8. Go over here. 1, 2, 3. And since it says greater than or equal to, then that's everything to the right side of that circle. So the whole number line, including the arrow,